Okay, we're back. This is technical video part 2, and I have everything connected up. And this is how I would connect things if I was to check out a board that was fully populated and ready to go out the door. By the way, I didn't say, I said I didn't have the resistor that I use. Here's the resistor I use. It's a 100 ohm, 100 watt resistor, and it's got a specific function of help controlling the firing of the SCR. And here's the actual capacitor I use. It's a 100, get it out, Steve? It's a 1500 microfarad at 450 volts. Pretty heavy duty. Although here I have a 1500 microfarad at 250 volts. It's doesn't have anywhere near the endurance that the big boy has, but it certainly is good enough for setting up and doing a test. I have the switches connected, and you can see the 3 wires. I have a yellow, black, and red wire. Red positive, black ground, going to ground on the board, and yellow is the selector position of the potentiometer, not potentiometer, but just switch. And here's the other one. Okay, so this one with the red dot right now represents speed, and the one without the red dot represents time. And I'll show you that again. I think did that in the main video. Here's a resistor I'm using in place of this one. It's a bunch of 20 ohms put together in series, so it performs the same function as this one does. I have a coil connected up, and I'll put the coil in front. Here's the coil. This is a bipolar coil. I'm not using channel 2, just using channel 1. Or coil 1. It's not necessarily the channel. I'll put this back here. And this is the start-stop button right here. There's a little button. And I'll just press it and, oh, let me explain one other thing. On the scope right here, you see half sine waves, or halfway rectified sine wave. And what I have here is 60 cycles. Everything's synced up, normal sync. I'm syncing on channel 1 right now, and you can see that from the wall outlet, I have the power connected from the wall outlet, and it is fused. It's definitely fused. I got an 8 amp slow blow fuse in what I'm holding in my hand. And here's the cord going to a power switch, goes to my distributor there. For 12 volts, I'm just using a regular 12 volt module, and this will come with the pigtailed unit, a connector for 12 volts, and although I would not normally be running this from a wall module, a vampire module, I run it from a internal power supply that's in the box. For testing, this works just fine. I don't have to turn around and put it in a box or anything and use a little power supply. All right, so this is basically all connected up to run, and if I click this thing, you can hear it. You can hear those little, in fact, I'll turn it up a little bit. I'll turn it to speed. It's at 1/2. I'll turn it to 2. Okay, so it's pulsing at 2 pulses per second, and you might be able to hear it. And you can see the pulses here. I'm going to sync on channel 2, the way I have the scope set up. And I can explain what you're seeing here. There's 60 humps, 60 halfway, roughly 160 volt peak pulses in a 60-second, in a 1-second duration period. This is what comes out of your wall outlet. We have 60 cycles here in the US. And I picked 3 of them, 3 in consecutive, and you can see where I'm pointing right now. There's a little glitch in the right-hand side of this hump, and that's when I tell the one of the SCRs fire and provide some juice to the cap, and it is sucking. Now I only had the time set for a minute. I'm going to change the time to 2 minutes. Okay. And then on the very next pulse, remember there's 60 of these happening all in a second, I say to the SCR, fire at a particular point and charge up the cap a little bit more. And then on the third consecutive hump, I say charge that cap right up to the top. So you can see the little swiggle when the cap sucks the energy from the wall outlet and charges itself. Then on the fourth hump, I turn around and I say fire and pulse the coil. And the coil gets sent all the juice from the capacitor, and it happens in roughly 3 milliseconds, and the cap is completely discharged. And one heck of a EMP, electromagnetic pulse. Keep it away from your computer. Do not put this coil near your computer. It goes out through the coil. This case is a bifurcated or bifiller coil. So that's the basics of what a populated board's like. You got a little technical intro on how it actually charges up the cap and discharges. Got a little visual on the scope. The essence of this is just amazing because there's really probably no more than $50, $55 worth of parts in here. All the rest is just labor. And how they can justify selling these units for $2,000 that are not significantly more powerful, if they are at all more powerful than this unit, I just can't imagine. So I'm going to be pricing this populated board here at $98. Don't ask me why I didn't go straight for 100. I just so 2 minutes just went up. A couple of other things I'd like to point out. The one reason why I really wanted to have this board done myself, or get these things out populated, is that I'm pointing right now to a thermistor that's it's not epoxy, that's a thermal heat paste. It's heat pasted to the outside of the SCR, and when the SCR gets too hot, that senses it, and the Arduino's monitoring everything, and it monitors. There's one on each one of these heat sinks. Each one of these heat sinks has an SCR mounted to it, and it decides whether it has to shut things down for a while to preserve everything so nothing burns up or blows up or whatever. Because if you run it at, I'll show you, if you run it at right now speed, turn it all the way up at 12 pulses per second, this thing starts to get really hot. And you can hear it pulsing in the background possibly. And it's pulsing according to the rules that I had posted in the other video. Runs solid 12 pulses per second for 5 seconds, takes a break for 1 second, and then goes back doing 5 seconds of 12 pulses per second. Okay, so looking at the video, this is about a little longer than the last one. So that's my technical intro. And what a populated board is all about, and voila, welcome to learning about PEMF. Until the next video, I will terminate this show. Nice talking to you. Bye bye.